So today we're going to talk about the chapter 3 of electronic devices and circuit theory, which is all about the bipolar junction transistors. So here we are going to discuss uh, from the transistor construction until its identification. So what is a transistor? So a transistor is a three-terminal semiconductor device that is used for amplification and switching purposes. So, transistor construction. So, there are two types of transistors. So, we have here a PNP transistor and the NPN transistor. So, the PNP transistor is consist of two P and one N-type layer material, while the NPN transistors consist of two N and one P. So, its terminals are labeled as the emitter, which is the E, as we can see here in this in the pictures, and the B is for the base, and C is the collector. So for the transistor operation, for example, we use here the PNP transistor. So we have here our external sources, uh, emitter voltage source and the collector voltage source. So in the first junction, the emitter base junction or the PN junction, we can see that it is a forward bias. So the depletion region is compressed. While for the base collector junction or the N to NP junction, it is reverse bias. So uh, our depletion region is stretched. Then for the currents in the transistor, so the emitter current is only based from the Kirchhoff's law. So this is equal to the sum of the uh, collector current plus the base currents. So for the collector current naman, it is comprised with two currents. So it is equal to the majority carrier current and the minority carrier current. So yung majority carrier current is yung junction na forward bias, while the minority carrier naman is yung junction na reverse bias. Now let's talk about the common base configuration. So here we're going to talk about characteristics of a transistor. So the characteristic of the transistor is are the plots which represents the relationship between the current and the voltage of a transistor in a particular configuration. So first we're going to talk about the common configuration of common base configuration. So the common base configuration. So the base is here. The base is common to both input, the emitter base junction, and the output, or the collector base junction of the transistor. So this offers low input impedance and high output impedance. Common base amplifiers. For the input characteristics shown in this figure, our output voltage VCB is kept constant. For example, it is constant 0 volts. So yung input voltage naman natin, or the VBA, will be increased in different voltages. So i-repeat lang yun. So here, a curve is drawn between the emitter current and the input voltage at the constant output voltage. Operating regions. So we have here three operating regions: the active, cutoff, and saturation. So first, the active region. So this lies between the saturation and cutoff region. So this is only operated by the transistor kung yung emitter junction niya is forward biased. Now for the cutoff region naman, so the amplifier is basically off. So here, ibig sabihin yung transistor is para siyang nag-open switch. So this means that the transistor only operates when both emitter junction and collector junction are reverse biased. Di ba nga kapag reverse biased is dyan yung nag-o-occur yung open switching. And for the saturation region naman, unlike cutoff, so this tends to behave as a closed switch. So yung cutoff region is open switch while this saturation region is closed switch. So this means that the transistor operates when both emitter junction and collector junction are forward biased. Approximations. So the emitter and collector currents. So the collector currents is only congruent to the emitter currents, and for the base emitter voltage. So our base emitter voltage for the silicon is still 0.7 volts. Alpha. So alpha is only the ratio of collector current to the emitter current. So our alpha for dynamic circuits is only equal to collector current divided by the emitter currents. Um, Ideally, if our alpha is 1, so in reality, alpha is between 0.9 and 0.998. Now, our alpha for AC mode is equal to the total current divided by total collector current divided by the total emitter current. Transistor amplification. So for example, here we have the PNP transistor. So we know that our emitter current is only equal to the entering current, while our collector current is equal to the leaving current. So our emitter current here is only equal to entering current so this is equal to the VI divided by the RI. So 200 megavolts divided by the 20 ohms. So this is equal to 10 milliamperes. So since our collector current is only equal to the emitter current, our IL will be equal to the entering current. So this our IL is only equal to 10 milliamperes. So to solve our leaving voltage, so equivalent siya sa leaving current times the resistor. So we know that our leaving current is equal to 10 milliamperes. So it will be multiplied to 5 kilo ohms, which is the resistor in the leaving voltage. So therefore our leaving voltage will be equal to 50 volts. And our voltage gain, to solve this, we are just going to multiply our leaving voltage by the entering voltage. So this is equal to 50 volts divided by 200 megavolts, which is equal to 250. Common emitter configuration. So here the emitter is common to both input or the base emitter junction and the output or the collector emitter junction. So this means that our input is on the base and our output is on the collector. So for the collector characteristics or the output characteristics as shown in this figure, so for example, we have our base current at 0. So this means that there is no current that is flowing. So our so there is an occurrence of the cutoff region. So and the VC is increased to different voltages. So parang i-repeat lang siya. So for the base characteristics naman or the input characteristics, so ang constant naman natin dito is yung VC natin. And so our VBA is increased to different voltages. So a curve is drawn to the between the base current and the input voltage, which is the VBE. Common emitter amplifier currents. So for the ideal currents, we know that our emitter current is only equal to the collector current plus the base currents. So our collector currents, as we know that our alpha is equal to the collector current divided by the emitter current. So therefore, by cross multiplying, our collector current is only equal to alpha times the emitter current. And for the actual currents naman, our collector currents will be equal to alpha times the emitter current plus the ICBO or the minority collector current. So what if yung base current natin is 0? So if yung base current natin is 0, we know that our transistor is in cutoff. But there is some minority current flowing. So may tinatawag pa rin tayo na ICEO. So to solve this is only equal to ICBO divided by the difference between 1 and A and alpha. So knowing that our base current is 0. Beta. So beta represents amplification factor of a transistor. So in DC mode, it is equal to collector current divided by the base current. Well, in AC mode naman, it is equal to change in collector current divided by the change in beta current and in base current. So for example, in this graph, so to determine the beta in AC, we have to find its change in collector current and change in base current first. So 3.2 minus 2.2 divided by 30 minus 20. So this is equal to 100. So our beta here is 100. In DC naman, so direct lang natin isi-solve siya. So our collector current is 2.7 divided by our base current, which is 25. Sorry, beta in DC is 108. Now for the relationship between amplification factors beta and alpha. So for our alpha, so will be equal to beta divided by beta plus 1. And our beta naman is equal to alpha divided by alpha minus 1. So our collector current will be equal to beta times the base current. And our emitter current naman will be equal to beta plus 1 multiplied to our base current. Now let's move to common collector configuration. So here our input is on the base and our output is on the emitter. So the characteristics are just similar to those of the common emitter configurations, except lamang dito sa vertical axis niya or the y-axis, which is changed into IC. So if the input current is equal to 0, this means that no current flows since the output current will also be 0. So the transistor will be in the cutoff region. So if the input current is slightly increased, then the IE will also increase. And so the transistor falls into the active region. Power dissipation. So for the common base, our Pmax is equal to VCB times the collector current. Or in common emitter naman, our Pmax is equal to VCA times the collector current. And for the common collector, our Pmax is equal to VCA times the emitter current. Transistor specification sheet. So here is our example for the 2N4123. So for off characteristics, we have the in the table we have the characteristics, the symbol, the minimum and maximum, and the unit. So for the we have here the off and the on characteristics. So for the off characteristics, for example, we have the collector to emitter breakdown. So here is its symbol. You can see its symbol and its minimum and so on. Transistor testing. So we have here the three ways to test a transistor. So first we have the curve tracer. So this provides a graph of the characteristic curves. So this allows you to analyze the characteristics of semiconductor devices. Next is the DDM or the digital multimeter. So this is used to measure two or more electrical values. For example, currents and voltages. Lastly, we have the ohmmeter. So this is to measure resistance naman. Transistor terminal identification. So here makikita natin yung kung alin dito yung collector, emitter, tsaka yung base. So sa first peak, makikita natin na yung para siyang perpendicular. So yung naka-vertical is yung collector, while the horizontal is either emitter or the base. Second naman is yung case is the collector. Sa third, makikita natin yung label. So here is the collector, the base, and the emitter. Same as the following transistors.